Just retry, okay? Retry joining. Because due to some technical problem, it was showing that the email will be removed and he needs to rejoin. So let him know if anyone is here. Let him know that he should rejoin. Okay, so up to the last class, do you have any doubt and confusion? So now degree of freedom, all of you will be able to solve that kind of problem. Degree of freedom related problem. Now are all of you are confident? Yes or no? Let me know, then I'll be able to understand. No? So I hope all of you will be able to find out degree of freedom. Yes. So for finding out degree of freedom of a mechanism, what are the basic steps involved? Who can tell me?
Draw the configuration diagram first.
Yes. Then.
Identify the number search link.
Yeah, different links you should be able to identify. Correct. Then.
So to find the fixed, note all the fixed links are with same number and
Okay. After that.
find P1 and P2.
P1 and P2. P1 means.
Lower pair.
Okay, and P2 is higher pair. Okay, and apart from that, if there is any redundancy, that you have to take care. Okay, so some other problems related to degree of freedom by yourself you try to solve. Okay, so today what we will do, we will be going for the different inversions of forward mechanism. Okay, or forward chain. So by this time, all of you already know what about forward mechanism, or you can say forward from forward chain. Okay, so if we fix one of the link, okay, what we get the forward mechanism. Okay, those things you already know. So now in one of the classes we have discussed about inversion of mechanism. So we have said that basically inversion is nothing but it's the process of obtaining different you can say mechanism out of the same kinematic chain when we keep on changing, or you can say one link definitely we have to fix for getting the inversion. And what we do, we actually like, we actually fix different links from the same kinematic chain, okay, one at a time, and we get different mechanism. So that process is nothing but inversion of mechanism. Okay, so we have said that basically will be interesting kinematic chains are like forward chain that we have got the slider crank chain. Already we have discussed about the slider crank mechanism. Also we have got double slider crank chain. So out of these three interesting kinematic chain, we'll be discussing about the different inversion that we get and what are the applications of it. Okay, so now the first inversion, first we'll be going for the forward mechanism. Okay, so after this much, if you have any confusion, you can ask. Otherwise, we'll start with the inversion of mechanism. Let me know if you have any questions. Anyone? No. Okay, then we'll go for the inversion of mechanism. So first inversion will be discussing as I have said that about the inversion of forward chain. So here what we do is inversion. How we get the inversion? By fixing what one link at a time from the same kinematic chain. That is important. So first inversion of forward chain is, we know that this is the basic forward chain that I can draw. Okay, so we are saying this is the link 1, link 2, link 3 and link 4, and this is the ground link or the fixed link. So what is the first inversion? So first inversion of forward chain is couple wheels of locomotive. You can see the application of this in the couple wheels of locomotive. So what is this couple wheel of locomotive? Locomotive means nothing but those trains that we are talking about. Sometimes we call it rail carry or train. Okay, that we are talking about by the locomotive. Okay. There you might have seen, as it is evident in the GIF, that is the video that is playing. You might have seen some wheels, okay, in the engine side. The wheels are coupled, mostly in the engine side, and that is nothing but actually as the coupled wheel of locomotive that we are talking about, and it is the first inversion of forward chain. So what does it have? Okay, basically it consists of four links, and the opposite links are equal in length. So here, as it a four-bar mechanism, basic four-bar mechanism itself, all of you already know. Four links definitely you have to have. But the interesting thing is the opposite links are equal in length. That is link one and link three. Similarly, link two and link 4, they are equal in length. Okay, so now in this particular case, here you can see this link 1, okay, this one, as well as this link 3, both are actually coupled at 2. You can consider this as one of the wheel of the locomotive, this is another wheel of the locomotive. So here they are behaving as crank actually. Okay, both of them, these two links are behaving as the two cranks. Okay, that means it's a double crank mechanism that you can think of. And link 4 basically is a fixed link, that is it is behaving like the frame. And this link 2, that is connecting the both the cranks from both the wheel, it is behaving like the coupling rod. Okay, and because of that, what basically happens, due to the motion of this particular wheel A, this is the wheel A, this is wheel B. Okay, so rotary motion of the wheel A, it gets transmitted to wheel B, and along with the motion of the wheel A, actually that means now wheel B also is moving. Okay, so there are certain advantages of actually coupling those wheels. Like one is the tractive force can be increased. Similarly, the slip that might happen in the rail, okay, that can be decreased. So I believe from the figure, then from this particular JF video, it's evident how basically this couple wheels are working. Okay. Okay, so this is about the first inversion. Now there is another inversion, that is the interesting inversion application of which is you can see in the beam engines. Okay, so second inversion of the what about for which particular chain? Second inversion of which chain? Which kinematic chain? The only second inversion, but second inversion of which kinematic chain we are talking? Anyone? You can tell me. We are talking about second inversion of the same kinematic chain, that is the forward chain we are talking about. But what we know, that is about inversion of mechanism. Basically, one link will be fixed, and that particular link that we keep on fixing is different. Okay. Now here, this is the application of PV engine. You can see here the AF. Okay, so those who are fascinated about the different Hollywood movies, you might have seen in the like in the cowboy type movies where old Texas, etc. Those places are shown. You might have seen some like some this kind of thing. Okay, in the deserts, actually, it is going up and down, or that way it is moving. Do anyone recall that kind seeing this kind of thing in the different western movies, those based on Texas and all? Okay, those cowboy like movies where basically different some oil rigs etc. are shown.
Western.
Anyone? Yes. Okay. So basically, this particular beam engine, this is evident in the different oil rigs and all. Okay, where continuously, actually, this is nothing but one another inversion of forward thing. Okay, this is known as the beam engine. So what happens here? So this particular mechanism is also known as crank and lever mechanism, because you will see that one of the like basically one of the link is behaving like the crank and one is behaving like the, you'll have one lever. Okay, so here basically what happens now, you can see in this particular figure. So we have this particular fixed link here that is numbered with 4. Okay, you can have any number, like You may give one, then everywhere in the fixed link you have to give number one or like that. Okay, so now this particular link here in this particular case, this here you can show that grain. You can see this particular length is nothing but that grain. Okay, so here in this left hand side figure, this is shown with link one. Okay, link number one. So it can rotate. Okay, as you can see here, whatever is shown in the left hand side in the in this particular right hand side diagram, those things are shown in the right hand side. Okay, that means this is analogous to this particular place in this particular figure. So now what happens basically due to this particular rotary motion that is there that is given in this particular crane. So all are actually pin jointed linked to that is having like the connecting rod. Okay. So this is pin jointed, and we have got one particular, we can say of here you can see here. Okay. So this link tree, the whole link tree, it is basically pivoted here. Okay. So pivoted at this particular portion you can see here. Okay, this whole thing is a link. It's not that suppose from here to here one link or from here to here one link. It's not like that, but the whole thing is a link, and it is having oscillating motion, and it is oscillating about this particular pivot. Okay, so on the this whole thing is link 3, and this is the link 4 we have here. Okay, and at the end of this particular link we have this particular portion attached, and what happens now, the continuous rotary motion which is there in this particular crane, okay, now it has been converted to this side. Okay, this up and the vertical portion, okay, vertical reciprocating motion. Okay, and this is how, like you can say, in the oil industries, oil rigs, etc., you see this particular portion which is responsible for doing different tasks. Okay, so this is known as, this particular inversion is known as beam engine. Okay, understood? I hope you have understood. Okay, so now the third inversion of forward mechanism is its application is in the pantograph. This is a particular device, very interesting kind of device, and this device is generally used to reproduce a displacement in a either in a reduced or in a enlarged scale. Reduced scale means what? You can either suppose if you have any reference diagram, okay, reference map diagram, any reference motion that you want to have, okay, so that can be traced, that can be duplicated either in a bigger size or in a smaller size. Okay, as per whatever is the size constant of that particular, how you design this particular pantograph mechanism. So this is very interesting, and sometimes in the exams also, in competitive exam, in the interviews also, it is being asked. Okay, which particular mechanism is the mechanism which is used to suppose reproduce different or duplicate drawings, maps, etc. is known as, the name is answer is pantograph. Okay, how basically it behaves. Okay, so it's basically is a kind of quadric cycle in the form of a parallelogram only. Okay, you can see in this particular figure where in the GIF we are showing how it is duplicating this particular heart shape. Okay, so some of you might be very interested, so because it is reproducing this particular heart shape. But apart from reproducing this particular shape, any kind of drawing, any map, etc., this pantograph mechanism, you can reduce or enlarge scale, it can duplicate. Okay, so basically this particular portion is guided through whatever is the desired diagram or drawing that you want to duplicate, and here this particular portion, at this particular portion you have the tracing point. Okay, and due to this particular uh, mechanism, okay, construction of this particular mechanism, here these are all pivoted here. So this is one, this being fixed here, you can see in this particular figure 48. Okay, so here by this particular dotted line actually different displaced positions are being shown. Okay, and other thing that is evident here. Okay, so whatever is the motion that you give here, okay, it is, you can see it is being traced here. Okay, so here all are actually turning pairs. Okay, turning in nature, and basically from the geometry of the figure, what, it's not like suppose if you just make something like this and it is going to duplicate whatever you want as per your requirement. It's not like that. You have to design it accordingly and properly to duplicate whatever is intended to do. So basic interesting basic point, okay, where you will be locating basically this particular point, at this end point is reproducing whatever is the or duplicating whatever is the particular diagram. So that means when if you want to draw or duplicate something, so your pen has to be here. Okay, so it's not like suppose as I have said, anything you make who looks something like this will be able to act like a pantograph. It's not like that. So from this particular figure, if you look at this particular figure, so basically from the geometric figure, this should hold good. That means AC by AC dash. Okay, so this particular distance, okay, should be proportional to AE by AE dash. Okay, so these are displaced position. These are the original position of this. Okay, so this is about pantograph mechanism. So we have this fourth inversion. So fourth inversion application, you see the work mechanism. So basically, this is, I believe all of you have heard about James Watt. Okay, so who is the inventor of this steam engine, right? So now in that particular case, while he was working on the steam engine, so actually he needed to guide that particular piston rod in a almost straight line fashion. And for that, actually, after doing successive so many iterations, so many trial and error, actually he came up with this kind of mechanism, which was able to give him the desired guidance to the piston rod in a almost straight line fashion. So actually to honor him, actually this particular mechanism, which was invented by Watt, James Watt, has been named after him. Okay, and we call it as Watt mechanism. So now here in the right hand side figure, you can see how it is basically working, and in the left hand side you can see the configuration diagram of the same. So here we have got link OA, this one, and link VC, this one. Okay, and they are acting like the V lever, and these are this way basically this is the mean position of the whole mechanism. Okay, and how they are connected, they are connected with a pin joint by this link A B. Okay, and here at this location and at this particular location O and C, they are fixed. Okay, fixed. So this is fixed link 4, link 1, link 2, and this is link 3. Okay, that means link 1 and link 3, they are nothing but the levers. Okay, link 2 it is connecting. Okay, so what basically happens, so due to the very nature of this particular mechanism itself, so for a small displacement of the levers, that OA and the BC. Okay, so the point D, which is there located on this particular link connecting the two levers. Okay, this point D, okay, it traces an approximate straight line. Okay, so approximate straight line means actually it's not a exact straight line. As you can see here, basically from here this portion to this portion, if you this red point, okay, red point, if you keep on tracking this particular red point, that is P point on the link L2 on this particular figure, then you'll see almost up to here, from here to here it's almost a straight line, and after that it deviates somewhat from the straight line behavior. That's why basically this mechanism, it falls under, actually it is tracing a approximate straight line mechanism. We'll later on see how we have got two different kind of straight line mechanism. One is known as the exact straight line motion mechanism, where the uh, uh, the tracing point, it actually traces an exact straight line. Now here you can see one example of an approximate straight line motion mechanism, where you can see the point of interest or the trace point, it actually uh, approximate straight line, but not a complete straight line. But for most of the duration, you can say around 80 to 85% of the motion of this particular trace point, actually it is behaving like a straight line. Okay, so now once again, it's not like that. Any kind of, like, suppose any point on this particular link, connecting link AB is going to actually give you this kind of straight line behavior. It's not like that. Okay, so there has to be certain relationship that must hold good. Okay, so if that is not happening, that means, you see, if you look at this particular video itself, it will be evident. So apart from this point P, if you consider some other point, suppose let's consider some point which is at the upper portion of this particular link L2, upper portion of this P. Okay, this point. So while moving, okay, you see how basically this not the right point, but some point you consider which is somewhat upper portion in the upper portion of this P. Okay, so it is actually not moving in a kind of straight line. Okay, they are debating somewhere, it is here, somewhere here, it is so much fluctuation is there, but actually this point is the point which is the ideal point for approximating a straight line. And this point D, it should be located on this particular link AB in such a way that the ratio AD by DB, this AD by this DB, it should be same as the ratio of BC by OA. That means it has got a certain relationship, okay, with respect to the two levers, length of the two levers. It's not like arbitrarily you just join something, okay, some link 5 pin join, and it is, you can expect that it is going to behave like that. It's not like that. So, but this particular relationship must hold good. Okay, so that is the these are the four inversion of your four-bar mechanism. Understood? Let me know.
Yes.
Okay, thank you. Now we'll be going for the inversion of slider crank mechanism. I believe all of you previously recall the slider crank chain, or ultimately the slider crank mechanism that we obtained from the slider crank chain. So now here also we have got different inversion, four inversions basically. So so the first inversion, as you can see, so first inversion how we'll get. So here in this particular figure, we are showing, I'm showing you the basic slider crank mechanism. I believe all of you recall how we have drawn the slider crank mechanism. Okay, we have got this particular fixed position here, and we have got this guide to of or guide or frame for guiding that movement of the slider. So we have got this link to is behaving like the crank. Okay, that can have the continuous rotation and motion, and link 3 that is connecting the endpoint of this particular crank to the slider. Okay, it's a connecting rod, and the link 4 is nothing but the slider. Those things I believe all of you recall, right? So when basically what happened? So just wait. So in our university internet has gone. So I'm joining by both actually my own mobile and laptop. So I believe the display is gone now, right? Just wait. It should come in a few seconds. Just wait. I hope it's visible now. Yes, it's visible, right? One second. Okay, so now here this is the basic diagram that we have done. So this first inversion of the slider can chain. Okay, once again we have got four inversions here. How we get? So this first inversion is obtained when this link one is fixed. Okay, right now we are link one means you should not remember like first inversion is by fixing link one, second by fixing link two, such like that. But you must remember which one we have considered as link one. Right now we are considering the normal whatever is the fixed link initially we discussed. Okay, that is the link one. So link one is fixed, and the link two, this link, and link four are crank and the slider respectively. That means it's the normal slider crank mechanism we are talking about. So its application you can see in the reciprocating engine as well as reciprocating compressor. But what's the difference between this team reciprocating engine and reciprocating compressor? Can anyone tell me? So basically, as you can see in this particular figure, there are two diagrams we are showing. Okay. So in reciprocating engine, so we are actually interested about the piston cylinder element that we are talking about. So in that case, the slider acts like a piston. Okay, and if we are talking about the reciprocating compressor, okay, then the and in that particular case, that means in the case of reciprocating engine, the piston is the driver, okay, and if it is a kind of compressor, then crank is the driver. So here you can see the you can see the frame portion has been modified to give you a kind of enclosure kind of thing. So in the different mechanisms, okay, these are the simple configuration diagram only, okay. So and these are the simple diagram, okay. So and second one thing, so this is joint, okay, this has to be, it's not like a different like it's not it should be been jointed properly. So now here in this particular case, what happens here, you can see this particular portion, this is being behaving like a uncloser, so that whenever actually this particular rotation is of the crank is there, so as you can see in this particular the F, okay, so if it is like this, then whatever is there, so whatever air etc it is there, it will be compressed, right? So that is behaving like the compression. Next, the second inversion of your, I believe from your manufacturing technology, all of you have studied about your quick return motion mechanism. Yes, have you heard about quick return motion mechanism from your manufacturing science or manufacturing technology subjects? Yes or no?
So in
Yes.
manufacturing process,
Okay, so what in manufacturing process or technology, whatever be the name of the subject. Okay, so there I have seen about quick return motion mechanism, na, which is generally used in the where, which machine, in the separ machine, right? That you see in this particular separ machine. So from the name itself, it suggests basically it's there are two strokes, that is the cutting stroke and the return stroke. And what is our intention? Return stroke, which is kind of the idle stroke, has to be faster, quick return. Okay, and we get the cutting stroke in a somewhat slower mechanism. And that second inversion, the application of second inversion of your slider kind mechanism is nothing but we have the without quick return motion mechanism as well as the rotary engine. So in both the cases, basically we use the quick return motion mechanism. So okay. So now once again here what happens? So if you look at this figure P, so this link, okay, if we link number two where it is mentioned here, okay, as link number two, that is just like the crank you previously have drawn. If we fix this, actually we get that second inversion. So the slider crank mechanism that is shown here in this particular figure, okay, so it can be drawn like this. Yes or no? You know that this way, if I draw like fixed, automatically means that the whole thing is fixed. Okay. So now further, when the link 2 is fixed instead of link 1, instead of this, if we fix this, you can consider we have rotated this figure. Okay. We have rotated. We have consider we have as if we have rotated this particular figure. Okay, rotated you can consider like that. Okay, and link 2 is fixed instead of link 1. Okay, uh, then link 3 along with the slider, that's link 3 along with the slider at its end P. Okay, this whole thing along with this particular slider behaves like a nitrular crank. That means it can rotate now. Okay, so this makes the link one to rotate about, you can say, this particular point O. Okay, about along about O, and the slider also, which is there, this particular slider reciprocates here. Okay, and that basically gives rise to the quick return motion mechanism. Apart from that, in the ray engine, which we have shown here, which is generally there in the you can say uh, uh, like that you can see in the front side. Okay, that is there. We have got this rotary engine. Okay, so what happens basically here actually we have got the common crank. Okay, on the face basically this different engines are there. Okay, and whenever actually this thing, okay, what happens, the different strokes takes place due to the motion of this. Okay, different stroke takes place at different cylinders. Okay, so that is about rotary engine. And without quick return motion mechanism, you already know. So forward stroke it is longer and cuts the metal, and return stroke is fast and kind of idle. And how they are behaving. So time of cutting by time of return. These things are already known from your manufacturing process subject. I think I have written like manufacturing technology. It should be manufacturing process, I think. So time of cutting by time of returns, and how they are uh, they're connected to the cutting stroke angle and return stroke angle. So the ratios would be same: cutting stroke angle divided by return stroke. And now we know the whole like 360 degrees there in that particular sense. So if in terms of your cutting stroke angle only we want to discuss, then it will be, if we denote cutting stroke angle by alpha and return stroke by beta, it will be alpha by beta. And I can also write like alpha by 360 degree minus alpha as the beta. Okay, and the next thing is similar, third and fourth inversion. I believe you can just go through third and fourth inversion by yourself, and in the next class I will be discussing about inversion of double slider crank mechanism. Okay, so with this for today we'll stop here. Let me know whether I have understood today's discussion or not. Anyone? Okay, so I'll be taking the roll call. Nilutpal, respond to your name calls. Nilutpal absent. Shankar,
Yes, sir.
Arshisman, Arshisman absent. Rehan,
Friends, sir.
Partha Patir,
Present, sir.
Rishikesh Basumutari, Rishikesh, see him previously. Miki,
Present, sir.
Nahosol,
Present, sir.
Nahosol, okay. Teza,
Present, sir.
Rishikesh Nath,
Yes, sir.
and Emil.
Sir.
Okay. Okay, so thank you everyone for joining. We'll meet in the
Thank you,
Thank
sir.
you, sir.
Thank
Yes,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.